How safe is a 60-minute signed URL? This is access control for stored files. It is part of security and authentication, and most people end up guarding the wrong line.
Here is the moment that starts this. You build an app, your users upload private files, invoices, scans, contracts. You keep those files in a private bucket in object storage. Object storage is just a service that holds files, and each file sits under a name called a key. Now your web page needs to show one of those files. The browser refuses. It says the request was blocked by CORS. You search for the error, you find the answer, and you add a CORS rule to the bucket. The error goes away. And then you feel worried. You just changed a setting on the bucket that holds every customer invoice you have. Did you make them public? That question is the reason for this video. The answer is not the one most people expect.
So let us name the subject properly. This is access control for object storage. It covers three things: who is allowed to read a stored file, how your server gives out that permission without the file passing through your server, and how long that permission lasts. This is not a lesson about what CORS is. There is already a video on the channel about that. It is also not a lesson about whether to keep files in a database or in a bucket. That is a storage decision, and this is not it. This is about the security properties of the answer everybody reaches for, which is the signed URL. Where does it matter? Anywhere a user uploads something private: medical images, bank statements, private video, course material behind a paywall. Every one of those apps hands out signed URLs, most of them with a number that nobody ever thought about.
Here is the picture I want in your head for the rest of the video. Two doors. On the left, a doorman stands in front of the door. Everybody who wants in shows him a photo card. He looks at the face. He looks at the card. He decides. He knows who went in. And tomorrow you can tell him that one person is no longer welcome, and he will turn that person away. On the right, there is no doorman. There is a small card reader on the wall, and on the ground in front of the door lies a key card. The card has no name on it. It does not care who picks it up. Whoever holds it walks in. Only one thing protects that door. The card stops working at a set time. Look at the clock on the ground. That is the whole security model. A signed URL is the right-hand door. It is not the left one, and the clock is the only dial you get. Before we go on, let us close the CORS question, because it is the wrong thing to be afraid of. CORS stands for Cross-Origin Resource Sharing. It is a rule that lives in the browser. It tells a browser which web pages are allowed to read a response using JavaScript. That is all it does. It does not decide who may fetch a file. It decides which page may look at what came back, and only a browser obeys it. A script, a command line tool, a program on somebody else's machine, none of them even read the rule. So adding your domain to a CORS policy did not open a door. There was never a door there. The door is somewhere else, and we are going to go and look at it.
The first setting blocks all public access to the bucket. That setting is still on. Nothing about CORS touched it. Then comes the CORS policy itself. Read every field. Allowed origins, which is your app's domain. Allowed methods, which is read. Allowed headers, and a cache time. Now read it again and look for a person. There is no field for a user, no field for an account, no field for who. A CORS rule cannot say who, because saying who is not its job. And here is the proof, which I ran before recording this. A small server that sends exactly that one allowed origin. Then curl asks for the file 3 times, once pretending to be the allowed page, once pretending to be a page that is not allowed, once with no origin at all. 200 OK every time. The bytes came back every time. The policy changed nothing for a client that is not a browser.
So let us draw what is really there. 3 parts: your browser, which is showing the page, your app server, which knows who is logged in, and the object store, which holds the file. The store is private. By default, it says no to everybody. Now watch the arrows, because the shape of this is the whole idea. The browser asks your app server for a link, and your app server answers with a link. That is one conversation going both ways. Then the browser goes straight to the object store with that link, and the file comes back. Both ways again. Now notice what is missing. There is no arrow between your app server and the object store. The file never passes through your server. That is exactly why people use this. Your server stays small and cheap. Your app server and the object store share one secret. Nothing travels between them. They simply both know it.
This is the code that makes the link. One call. You give it the operation, getObject, which means read. You give it the bucket and the key, which together name exactly one file. And you give it expires in, counted in seconds. 3,600 seconds is 1 hour. That is the 60 minutes in the title of this video. Now here's the part that surprises people the first time. This call does not talk to the object store at all. Nothing is registered anywhere. No row is written. I proved it before recording. I broke every network socket in the process first, so any outgoing connection would crash immediately. The link was still produced. It is pure arithmetic, done on your own machine. Which means the object store has never heard of this link, and it will still accept it. Remember that, because it explains everything that comes next.
So what is inside that link? The signature is a fingerprint taken over a short list of facts. The bucket, the key, which is the exact file name, the method, read or write, the moment it was signed, the number of seconds it stays good, and a secret key that never leaves your server. Change any one of those and the fingerprint changes. I tried all of them. A different file gives a different signature. A different bucket, different signature. Write instead of read, different signature. A different expiry, different signature. A different secret, different signature. Now look at the other column. These are the things the signature does not cover. It does not cover who you are. It does not cover which computer you are on. It does not cover how many times the link is used, and there is no field in it for cancel.
Here is why the object store does not need to have heard of your link. Watch what it does when the request arrives. It takes the parts of the request it can already see: the method, the path, the query, the host. It puts them in a fixed order, and that block has a name. It is called the canonical request. It hashes that block and puts the hash into a second small block, together with the date and the region. Then it builds a signing key by running a chain of keyed hashes, starting from the same shared secret. A keyed hash just means a hash that mixes in a secret. Finally, it signs the block with that key. Out comes a string. If that string is equal to the signature that arrived in the URL, the answer is yes. Now look at what is not in there. No database, no session table, no lookup of any kind. I wrote this by hand and compared it against the real library. Same input, same string, character for character.
Which brings us to the sentence that matters. The URL is the credential. It is not a pointer to a permission that lives somewhere else. It carries its own permission inside itself. Anybody who holds the string is authorized. No login, no session, no idea who they are. If you have met access tokens and refresh tokens before, this is the same family. It is a bearer token. Bearer means the holder. Whoever holds it gets in. The one difference is that a normal token usually travels in a header, where it is a little harder to leak by accident. This one travels in a URL, and URLs get copied.
So let us put a stranger on the picture. Nothing about the system changes. Same 3 parts, same arrows. The only new thing is that the string got out. Maybe it went into a chat message. Maybe it ended up in a log file. We will go through the list in a second. Now look at the bottom arrow and compare it with the arrow above it. They are the same arrow. The stranger asks the object store for the file, and the file comes back. The object store cannot tell the two apart, and I want to be precise about why. Not because it is badly built, because there is nothing in the request that would tell it apart. Same signature, same bucket, same key. It does the same arithmetic, and it gets the same yes. This is not a bug. This is the design working exactly as it was specified.
So how does a URL get out? Usually not because somebody attacked you. It gets out because ordinary software does ordinary things. When a page links onwards, the browser tells the next site which page you came from. That is the referrer header, and the whole URL rides along inside it. Somebody pastes the link into a support chat to show the problem. It sits in browser history on a shared computer. It goes into a proxy log, a load balancer log, a CDN log. It appears in a crash report sent to your error tracker. Somebody takes a screenshot with the address bar in it. A user forwards the email that contained it. None of that is an attack. That is an ordinary working day, and every one of those copies keeps working.
Now the arithmetic.
because this is where a number in a config file turns into a real thing. Your setting says 3,600 seconds, 1 hour. Say the link leaks 3 minutes after it was made. It keeps working for the remaining 57 minutes, for anybody who has it. That is your leak window. Now shrink the setting to 60 seconds, and the worst case drops to 1 minute. But the same person watching for 1 hour now needs 60 new links instead of 1. With 5,000 people watching, that is 300,000 signing requests an hour instead of 5,000. The dial has 2 ends, and both ends cost something.
So here is the shape of the fix, and notice that most of it is not about signing at all. The link is created behind a normal logged-in endpoint. Let us go line by line. First, who is asking? That is the ordinary session check you already have. Second, are they allowed this particular file? That is a real ownership check against your database, not a guess based on the file name. Only then do you sign, and you sign short. 60 seconds is enough for the browser to follow the link. Then you return it as JSON to a page that already has a session, instead of putting it in a link that gets shared around. This is where your identity check lives. It lives here before the signature exists, because after the signature exists, there is no identity check anywhere. Both of these columns are true, so choose knowing both. A short expiry, 60 seconds. The leak window is at most 1 minute. The cost is a signing request for every view, and things break in ways that will surprise you. A big download that takes longer than the expiry can fail partway through. A video that the viewer jumps around in needs fresh links in the middle of playback. A tab left open overnight shows broken images in the morning. Now a long expiry, 1 hour. Everything is smooth. 1 link, 1 call, no strange failures. And the leak window is a full hour for anybody in the world who ends up holding that string. There is no correct answer here. There is only the file. A public marketing image can have a day. A medical scan should have a minute. And one more thing, which is the part people find out too late. You cannot cancel a signed URL. There is no delete button because the object store never stored it. It is not in a list anywhere. It is arithmetic, and you cannot undo arithmetic. There is exactly one emergency switch, and here it is on the picture. Change the secret. Rotate the signing key. Now the store computes a different answer, so the leaked link stops working, and so does every other link you have ever handed out, to every user, all at once. That is an emergency switch, not a control, which is why the expiry is not a small detail. It is the only revocation you have, and you decided in advance. So, back to the question we started with. Your CORS setting decides which web page is allowed to read the response. Your signature decides who is allowed to read the object. Only one of those is a security boundary, and its whole strength is a number in a configuration file. The bucket staying private, with no public address on it, is doing far more work than the CORS line everybody stares at. A 60-minute signed URL is exactly as safe as the worst thing that happens to that string within 60 minutes. So go and find that number in your own code today. Ask what happens if that exact string ends up in a chat window. Then set it on purpose.
That is signed URLs and expiry. If this was useful, a like helps more than you would think, and subscribe if you want the next one. Thanks for watching.